All right. Well, hello, everyone. Welcome. Good afternoon, good evening, good morning from wherever you're joining us. My name is Dalia, and I work as a community manager here at Kong. I'm very happy to welcome you to our tech talk today. You can see the topic getting started with TargetRef policies in Kong Mesh. Very interesting. We have Charlie with us today. I will let him introduce himself. Let's take all of the questions at the end. So if you have a question, you can see a Q&A function on the bottom. Please insert your question there rather than the chat. This webinar is recorded, so you will find the recording in about an hour or two on our YouTube page. I will post the link in the chat so you have access. And yeah, Charlie, please take it away.
Yes. Hi, I'm Charlie. I'm the engineering manager for Mesh at Kong. I manage the engineering team that builds Kong Mesh that heavily contributes to Kuma, who's the CNCF project that Kong Mesh is based on, and what we call SaaS Konnect, which is our Kong Mesh offering as a SaaS. So here I'm going to tell you a little bit about our TargetRef policies and about the new features in Kong Mesh 2.6, including a demo that will showcase as well Connect and Meshing Connect. Okay, so let's get started. I'm going to start very quickly because you might not all be familiar with Kong Mesh, with a very quick overview of what Kong Mesh is and what it's for. And then we'll jump in the demo, and then finally we'll have a Q&A. Okay, cool. So Kong Mesh. So there's three types of connectivity, really. There's edge connectivities. So that means from your, the public traffic coming inside your organization, right? There's cross-app traffic, as in if you define an app as like a set of services that work together, you probably have a common set of APIs at the top that is the entry point to this, right? And so your different business units will communicate to different apps, right? And then you have the last bit, which is what we call in-app connectivity. So this one app I talked about is probably built of multiple microservices, right? And to secure and control the communication between these microservices, you probably want to use a service mesh, right? And that's where it fits in. So if we go about our service mesh specifically, which is Kong Mesh, why do you actually need a service mesh, right? One big thing is discovery and traffic reliability. So Kubernetes gives you some of it, as in you get some level of discovery, but you don't really have any reliability offering in Kubernetes. So what a service mesh offers you is the ability to configure timeouts, to configure retries, to configure failovers, and all this. And in the case of Kong Mesh, it doesn't only limit itself to inside a Kubernetes cluster. This also applies across different Kubernetes clusters. Okay, then next up is zero trust and security. So what you get with the service mesh is MTLS everywhere, right? So all your traffic is TLS. There's an identity for every single instance of your application, and you can easily control who can communicate to who in a very secured manner and a very fine-grained manner. And the very last but not least feature is global traffic observability. So that means you can get all of logs, traces, and metrics across all your different apps that run inside your service mesh. Okay. So why would you want Kong Mesh, right? Because Kong Mesh is the best suited for enterprise offering. You can do multi-tenancy, so you can have different business units that work very independently in a multi-mesh use cases. You can run this on Kubernetes, but also very easily on VMs. You can also run it only on VMs and not even have a Kubernetes cluster if that's something you're not interested in at all. And then it has a very easy and straightforward way to do multi-zone connectivity. So that means you can connect your different clusters of VMs, of Kubernetes, of a mix of everything together so that application can discover one another and communicate to one another very easily. It's all powered by Envoy proxy. For those who don't know about Envoy, it's probably one of the most popular proxies around. It's part of the CNCF, It's been heavily used at Lyft, where it's originated, but it's also heavily used at Google, at Microsoft, Apple, at the big ones. It's a very reliable piece of software, and which is why we picked it as a proxy for a service mesh. Okay, cool. There's a few things being said about us. That's it. But let's get into a little bit of a high-level architecture. The choice we've made for Kong Mesh is and multi-cluster is what we call federation. So we have a global control plane at the top, and then we have zonal control planes that for each of your cluster that works independently. The advantage of this is that you can lose global, you can lose some of the zone, etc. Things will still work. It also scales very well because each of the zone actually scale independently, right? The only thing that the global has is control and the ability to see over all your other clusters. And then if you want to communicate across your clusters, you will use a specific proxy, which we call the zone ingress. So you probably have a checkbox of the things that you want in a service mesh. And here's a few features that Kong Mesh will offer, right? It's multi-cluster from the get-go. It's not something that's been added later. It just works like that. It's also multi-manager. So you can easily have multiple tenants, so typically multiple business units that will work on the same infrastructure, but do not share information. It's compliant with Gateway API. It's compliant with Gamma, which is the mesh-specific part of the Gateway API specification. It integrates pretty well with cloud services, so serverless, secret managers, VMs, and things like that. It embraces open telemetry for both for all metric, logs, and traces. And it integrates with any API gateway. So we have this concept of delegated gateway where you can use, for example, Kong Gateway to actually receive your external traffic inside the mesh. What we also offer at Kong is what we call Konnect, which is our SaaS. Konnect is very unique because it can follow you over your all API lifecycle, right? You can use Kong Insomnia to build and consume your APIs. So design your API, test it, etc. You can use Kong Gateway and the ingress controller that we have to actually receive traffic from the outside inside your application. And this is all controllable through Kong Connect. And then inside the app, you can use Kong Mesh to actually control all this. And all this is all workable and manageable from a single control plane, which is Kong Connect. And this control plane, it's a SaaS. It's heavily secured. It's heavily reliable. It comes with high level of guarantees. And this is one of the main reasons why you'd go for a SaaS, right? In the case of a mesh, we'll just end up having the global control plane that I've shown earlier running for you inside Connect. And we'll show that in a little bit in a demo where I'll migrate from an existing cluster to a cluster running, to having a global control plane in Connect. Okay, so if you already know Kong Mesh, you might want to know what we've just released. We released version 2.6 last week. And here are the things that are new, the main changes, and the things that I'm actually going to demo just after. So you can apply policies directly to zones. Prior to that, when you were in the multi-zone setup, you had to apply policies to global, and then they would propagate down. You can still do that, but now you can also, if you want your policy to only impact a single zone, as in your Kubernetes cluster, you can apply the policies directly there. This was a highly requested feature for people that are Kubernetes native and do manage their policies in a different way. So for example, they have Argo CD that will apply policies one by one, right? We also made a thing. For a while, we've been working on these new types of policies that we call TargetRef policies. They're very powerful, And so we replace progressively our prior versions of policy with these ones. With 2.6, we're very happy to make these new policies default. This means it's much easier to get up and running with Kong Mesh with a much stronger expressive types of policies. We also made it incredibly easier to go from a single zone to a multi-zone setup, as I'll show in the demo. And then you can also use our existing mesh HTTP route and our existing mesh TCP route with our existing built-in gateway. Okay. So now if we look a little bit about this TargetRef policy, which is one of the very powerful things of Kong Mesh. So they all look roughly like that. In that case, we're talking about a timeout policy. And there are two main families of policies. There are from policies and to policies. From policies are policies that apply to traffic that your proxy receives. So traffic coming from the mesh to your proxy. And to policies is the opposite. It's traffic going out of your proxy to the rest of the mesh. Each policy have what we call a top-level target ref. This top-level target ref enables you to very strictly identify the set of proxies whose configuration are going to get impacted. So in that case, we're going to pick all the proxies that have the label team equal to A, and only these proxies. This is very powerful if you want to slowly and progressively roll out a policy without breaking everything at once. You can start very small, identifying very specific proxies, and then roll it out progressively to everything. And roll back if you want. You can do the same thing on the type of traffic and the destination or source of the traffic. So in that case, you can say, my timeout, I apply it to the traffic coming from the entirety of the mesh. So any traffic going to my service, I want to have a request timeout of 2 seconds. So whenever I receive traffic, I'm going to set a 2-second timeout. So you can do the opposite, as I just showed. Here, we pick all the proxies that have a tag of version v0. And when they reach the service, my namespace service AT will apply a request timeout of 5 seconds. So here, only the traffic going to this specific service will get impacted. The rest of the traffic will stay unchanged. Okay, so now let's get to a demo. I'll just show quickly the little setup that we've got running because it will help understand the whole demo later. So we have an edge gateway, which is a built-in gateway that has a single route, which is / that routes the traffic to our service 0, right? Whenever service 0 receives a request, it will send 2 requests, one to service 1, one to service 2, right? And service 2, to fulfill the request, will call service 3, okay? It's just a little toy setup so that we can get. Okay, so because I'm very bad at live typing, the entire video is recorded. Get it. Hi. So in this demo, we'll install a zone control plane that we will then transform into a multi-zone setup by using our SaaS Konnect as the global control plane. This is very straightforward. So once we've done that, we will use our policies and play with timeouts to actually show the power of our TargetRef-based policies. So I've already installed the zone control plane by just doing helm install. And I've created my workload. As I've showed in the slides previously, the workload is fairly simple. It's 4 applications with service 0 that talks to service 1 and service 2 to fulfill a request, and service 2 will call service 3 to fulfill the request. Okay, we can see our mesh has a CA enabled, right? It has a mesh traffic permission for the traffic to be able to go out, and we define a gateway with 2 instances. This gateway is called Edge Gateway, and we have a mesh gateway that has an HTTP listener on port 80 and a mesh HTTP route that goes from Edge Gateway to API Play 0. Let's test it out. So here, if we curl, we can see that service 0 actually called service 1 and service 2, and that service 2 actually called service 3. Could do that a few times if we want. And then if we go to our data plane proxies and we look at API Play, we can see here that some requests were actually sent and received. Okay, nice. So let's get to the more interesting bit now, which is we're going to use Konnect to be a global control plane. So our very first step is we're going to create a new control plane, my new demo. I create it here, and it's available here. I'm going to create a zone, my zone, and then we're going to ignore this a little bit because we already have a control program. So we're going to just take the secret and apply it to our Kubernetes cluster, and then we'll take this for later. Now that we have done this, what we will take is we will use this new command to actually export all the useful configuration from the zone control plane that will then apply it to the global control plane. So here we do it here. We can look at resources here, and we can see here that we have our mesh. We can see our mesh as the CA, etc., right? And then we have the CA that is actually useful with the key and the certificate, so that when we actually migrate, we won't need to regenerate new secrets. Everything will still be on the same CA. Okay, and then we have some internal entities. So now that we connected there, we're gonna now connect to our global control plane with Kuma. Here's how you do that. Up, we've got it here. So here, if I do Kuma get meshes, you can see there's default mesh and it doesn't have MTLS because this is the default mesh that is created automatically. Okay. So now I am going to actually apply the resources I've created previously. Kuma apply resources. And I'm going to delete the built-in resources from the global control plane. That way it will be small and simple and we can get started easily. Now the next step is going to actually restart our zone control plane so that it actually connects to Konnect. So for this, we're going to do a Helm upgrade using the values connect that we've got from the Konnect UI earlier. This is going to take a minute. Okay, so now it's here. We can check the pods and we can see that the control plane is starting. Might be worth waiting until the old one is actually fully terminated because the new control plane doesn't fully take over until this is done.
So just wait a little. Okay, so now if we go back to our Connect GUI and refresh it, our zone should soon appear on the online. Sorry. Here we are, the zone is online. Now, if we go back to our mesh, we can now see that we have our services, our 5 services that run on the zone control plane. And we have all our data plane proxy. You can see that these data plane proxies have actually got my zone. What is even cooler is that now from this SaaS, you can actually access all the stats that we were looking at earlier. This is quite nice. So, and we can also check with curl that it all works, right? No interruptions of traffic, it all worked all the time. This is quite nice. So now that we have set up a multi-zone setup, we can add more zones if we want, but that's not what we're going to do now. What we're going to do is explore what we can do with our TargetRef policies and more specifically mesh timeout. So to do this, we're going to use a feature of our tool application that we run here that's called API Play that enables us to inject some latency. So you saw earlier that the call was almost instant when we were calling the gateway. So this API, this application enables us to edit a config map and inject some latency. This latency is going to be between, so that all the calls to API Play 0 are going to take between 1 and 2 seconds to actually respond. So it can take a second before it takes effect because this is all based on config map in Kubernetes, and config map in Kubernetes can take a while to actually propagate. Oops, sorry. Here, we can see now it takes over a second to actually reply. Okay, that's a good thing. So now let's apply our first policy. Our first policy is going to be timeout 1. What this timeout does is that it's similar to a mesh administrator deciding that all the applications running in the mesh should follow good practices and have an upper bound timeout, right? So this is good to limit tail latency, as in anything too long shouldn't be shouldn't actually happen. So here we're going to be very opinionated and we're going to say 1 second, which is probably a bit too strict, but this is a demo, right? So we apply it, it's there, and now if I try to curl, I need to remove this because we're actually getting a request timeout. If I look at -v, we can see that the timeout is a 504 on the gateway. So how do we fix that? The way we fix that is with another timeout policy that will say that for all my gateways, when I reach API Play 000, I actually want to have a request timeout of 4 seconds. So I can do kubectl apply -f timeout 2. And now if I curl, I can actually see that it works just fine. Okay, now it works. It takes over 1 second, but it still works. Okay, so how about we explore a little bit more and we add more latency to another service. So we're going to add latency to our tail service, API Play 3. So if you remember, my gateway calls API Play 0, API Play 0 calls API Play 1 and API Play 2, and API Play 2 calls API Play 3. So if I increase the latency to API Play 3, the call for API Play 2 will also be longer. And same for API Play 0. So let's do it. I'm going to do edit again. And I'm going to inject the same latency as I did before. Okay, 1 second. This is going to take a bit of time, as I showed. So it's still working. Still working. Here. So here we can see we got a 504, we got a gateway timeout. Okay, so now let's try to fix it. So the first thing we're going to do is to do Kuma is to apply this first policy. This first policy actually says that API play 0, when it talks to API play 3, it should have a timeout of 2 seconds. This is a purposefully wrong policy, because obviously API play 0 doesn't directly talk to API play 3. So if we do this and I redo my curl, you can see it's still timing out. Okay, so let's have a look. If we look at my policies here and we look at mesh timeouts, we can see that mesh timeout, when it's talking to API play 3, it has a request timeout of 2 seconds. If it's not talking to API play 3, it has a timeout of 1 second. So that must be the problem we have, right? So let's try to fix it. So we have here timeout 3 fixed. That is actually going to do what we want. So we're going to say that API play 2, when it talks to API play 3, it should have a 2 second timeout, right? And API play 0, when it talks to API play 2, it should have a 2 second timeout as well. So let's try to apply that. Okay, we've got it here. Now if we refresh here, we can see that now it's API play 2. When we talk to API play 2, it actually has a 2 second timeout. Otherwise, it has a 1 second timeout. Okay. Okay, so 200, okay. Looking better, right? Here we are. So now, if I go back here, you can see we've got the outbounds. We had like some 500s from when we were timing out, but now we only have 200s, right? If I do a couple of extra calls. We can see there's 19 calls now. If we go to a data plane for API play 2, right, and you look at the policies, we can see if we've got a mesh timeout, and in that case, our policy is different, right? So it's our timeout free policy. So when it's called API play 3, it actually has a 2 second timeout, and when it's not, it has a 1 second timeout. So here it is. Here's how I showed, and we can go to policies to see all the policies together. We have our mesh timeout, and we have our four different policies, sorry. We have our 4 different policies. So we've got one that has mesh timeout that applies a global default of 1 second. And then we have specific ones. So the gateway, when it calls to API play 0, will have a 4-second timeout. One for API play 2 that will have a 3-second timeout, right? And one for API play 0 that will have a 2-second timeout when it talks to API play 2. So here's how we showed everything you can get from the GUI to actually get stats and understand what happens. How you can look at policies, you can easily see the affected data planes of a policy. So the data planes that will receive configuration changes from this policy. You can easily see the different outbounds and inbounds to actually see how the traffic goes through. And you can see the policies directly and see directly the configuration depending on where the traffic is going to be able to very easily figure out what you want to do. This enables you to leverage the power of our TargetRef policies to have a very granular configuration that can be shared between enforcing good practices at the mesh operator level and still giving the freedom of service owners to step away from it in order to achieve what they actually need. These granular policies and TargetRef can go even further. It makes it very easy to slowly roll out a policy to a set of proxies. So for example, you can roll out, during an outage, you can roll out a policy to only a single proxy to see if things improve. If things don't improve, you can delete it. But if they do improve, you can then progressively roll it up to the entirety of the mesh if that's what you prefer. So here it is. We showed the power of TargetRef policies. We showed that it was very simple to take your existing Kong mesh setup and connecting to Konnect with very seamless and easy transition. And I hope you'll give it a try and give us feedback. Thanks.
Hey. Yeah, so that's it. I think we can go into Q&A now.
Thank you, Charlie. That was great. Let's see if we have any questions. We have one question so far.
On top of services running in different clouds, no, we haven't. That's not what we're doing in this meeting, but there's definitely something we could do in a future webinar. It's actually very easy to do it in different public clouds. Like you saw how I Helm installed it, and that was running on JKE, but that would just work the same in like EKS or AKS. You just Helm install, it works, and then if you specified your Konnect configuration in the Helm install, it will start reporting up there, and then it will be able to discover each zone using the zone ingress. So you can also get cross-cloud traffic quite easily thanks to that.
Let's see if any other questions will come through. Any questions for Charlie before we wrap up?
Don't be shy.
Yeah, don't be shy. Also, the webinar will be posted in a couple hours, the recording on our YouTube channel. The link is in the chat, so you can subscribe and stay up to date with everything we're doing. Oh, one more.
Can you really shortly explain more attributes to change in the zones? I'm sorry, I'm not sure I fully understand this question. What do you mean by attributes? I think you can probably just re-explain some more in the chat, maybe. So more attributes change in the zones. Oh, you want to know which other attributes do exist in the mesh timeout? Is that it? We can show you in the docs, but there's quite a lot of them. If we go to mesh timeout, you know, for example, for HTTP, you get the request timeout, the stream idle timeout, the max stream duration, connection, the request headers timeout, and things like that. There's a lot of them. There is in the demo, I deleted the safe defaults because I wanted to make the simplest demo possible. But whenever you create a mesh by default, we install a default timeout policy that has like a request timeout of 15 seconds and then a bunch of the other timeouts set to good defaults. And then, like, I've only showed mesh timeout, but you get all these types of policies, right? You get mesh fault injection, mesh circuit breaker, and all this as well. Mesh trace, mesh metric, and mesh access log is the trio for observability. And that's it.
Let's see, any last questions? Nope. All right. Well, thank you, Charlie. Thank you for the great presentation. And thanks everyone for joining. I hope you enjoyed it. Recording will be available in a couple hours, and I hope to see you at our next webinars. I hope you have a great day, great evening ahead, and see you soon. Bye.
See you. Bye-bye.